Welcome to Tech Talk IT, powered by Software Mind.
Hello, clever people. My name is Victor, and today I'm gonna talk to you about an alternative quality model. Now, I've been in the software industry for around 13 years, since 2011, and I've kind of went from various roles, jumped from various roles. So I started as a software developer. I've jumped to automated testing. I've done a lot of leading in the quality space. I've jumped back to development, so I've been a technical lead, and now I'm doing quality consultancy. So I have kind of seen the ins and outs of the software quality cycle and in general the development cycle. Now, I mentioned that this is going to be about an alternative quality model. Why an alternative? Well, I've mostly worked with quality assurance for most of my life, and I'm guessing most of you guys have already. Indeed, quality assurance is almost like the industry standard. And even though in this kind of presentation, I'm gonna talk about some of its downsides, rest assured, it works. So no matter what I'm gonna say now, it does work. It does a good job. It delivers quality software. However, it does have some downsides, and we are gonna look at those downsides, and then we are gonna kind of look at an alternative to this process and mentality, and kind of look in a way compare these two. So, quality assurance. Quality assurance has this promise, right? So while you develop something, you test it, and the bugs are being found, and you fix the bugs. And I'm gonna talk a lot about an agile process here. So most of what I'm gonna say represents usually the Scrum approach to agile. So I'm gonna talk about sprints. So, we're looking at a development cycle, right? When we look at the development cycle, usually testing should happen from top to bottom while development is happening, and you test while you develop, so you find defects and you fix those defects in an iterative process, and in the end, you release a good quality product. That's the promise, right? Well, I'm sure you know, this is not reality, how reality usually looks like. Usually in reality, development happens at the beginning of this cycle, and then towards the end of this cycle, you have testing and you have bug fixing, and then you release. Now, at the beginning of this cycle, usually testers do something, let's say, quality assurance activities, right? So, that usually means analysis, feedback on the features which are going to be developed, test cases. We are going to touch quite a bit on test cases. So basically, planning your testing activities without even seeing the product, seeing what you are gonna do, seeing how it looks like, right? You plan, and this planning is usually very strict. You have those steps, right? And then when it comes to testing, you tick the boxes. Yes, this step passes, this step passes. So this is how kind of quality assurance ends up looking in reality, right? And the reality is, testing is usually crammed at the end. So this means that the release doesn't come after a sane amount of testing and feedback healthy amount of testing and feedback. It's usually, we have to respect milestones. So this means that we have to kind of release earlier than, the quality team, let's say, says, yes, we do have a quality product. Usually we release when there are no blockers or critical blockers. So we kind of, our customers expect some defects. That's fine. So most of the defects become post-release improvements, right? Quality assurance. I'm sure you've heard about it. There's a ratio of, let's say, in quality assurance, right? When we're talking about more conventional software development here, right? We're talking about, let's say, the 70% of the IT market. So we're not talking about the very special cases, let's say military or pharma, where all of these ratios that I'm going to talk about now are not going to be the same. For example, in pharma, you have maybe 100 testers per one developer, because that's a whole different thing there. There are people's life at stake. But here, in our conventional software development, we are talking about usually 2-to-1 or 3-to-1, right? So that's 3 developers for 1 tester, or 2 developers for 1 tester, or the other way around. You know what I'm talking about. So what this means in quality assurance is that when you scale up the team, the development team, so when you want to increase the throughput, increase the amount of work which is being done, you also need to increase the testing team, right? Cool. Keep that in mind. We are going to kind of turn back to it in a minute. So, quality assurance basically means testing at the end. What it means for a developer, it means that you develop something and then you throw it over the fence to somebody else to make sure it's of good quality. So it kind of promotes a development culture in which quality is someone else's responsibility. The quality gateway, right? Testing in quality assurance is usually crammed at the end of the development cycle. This kind of brings some disadvantages to it in itself. So the QA team is usually held responsible for software delivery issues, even though, of course, that's not true, but just because of this, because it's crammed at the end. Why are we being late? Well, of course, we're being late because of the last thing that happens before release, which is testing. And, testing is never something kind of really predictable. You can never really predict the kind of defects that you are going to find, or the severity of the defects which you are going to find. So this means that, when the software gets into this phase, it's very, this phase is hard to estimate, right? You can find a huge defect, something that nobody has talked about. So, okay, so we cannot release because it's still in testing. And basically, having people checking that the quality is good at the end of the chain does not magically bring quality. It patches things up. It kind of brings a very nice and a respectable product to the customer, but the quality won't be there in the next iteration either. Defects are still going to be introduced. You as a tester will still have to kind of act as the quality gateway, filter out these defects, and then show it to the customer. I would also want to kind of talk a bit about the distance between introducing a defect and finding a defect. So again, I'm looking at this axis, which is the software development cycle, let's say. So it's an iteration, right? We if we look at it from a Scrum perspective, it's after the sprint planning, and the sprint has started, and everybody's working on the features that need to be developed. So the developer starts, you as a developer, or whoever is watching this. So as a developer, you start developing something. You load everything in your head. You load the architecture, you load the designs, you load your approach, you load your algorithms, and you start programming the feature that needs to be delivered. And you program it, and you introduce a defect. You don't know that you have introduced a defect, especially if it's a more business-oriented defect, right? Usually, of course, developers do testing. They tend to kind of do more technical-oriented testing, a more unit-based testing, right? If we think about it. Either way, you introduce a defect at the beginning of this development cycle. Then towards the end, so you program, you finish, and you say, okay, my tester, here's the work. You throw it over the fence. A lot of time has passed. The tester cannot start testing right away. Maybe he has some analysis to do, maybe he's testing something else, there are tasks to be done. So the tester will start testing when he has the chance. In the meantime, you as a developer have to switch context. You have to offload everything. You have to, load something else into your head, right? Other algorithms, another journey. And the tester comes with a defect on your previous work. The distance between introducing the defect and finding the defect in quality assurance usually is big. And this in itself causes a lot of issues, right? I, as a developer, to fix this defect on my previous workflow, I need to mess up the algorithms that I don't have in my head anymore. I need to kind of reload a journey that I don't have in my head anymore. So it's, kind of causes a lot of issues in itself. So fixing defects a long time after they have actually been introduced, because they were detected a long time after they've been introduced. When I say a long time, I mean 1 week, 2 weeks, so it's not a year. These are obvious defects, right? We're not talking about the finer ones. Cool. So the issue is kind of this. Another issue of quality assurance is this kind of big gap between introducing and fixing. Of course, I kind of also mentioned that the fact that we have these test cases, which are really imperative, affect the way testers value their work. So instead of being creative, instead of using all kinds of heuristics that I have learned, instead of using my tester mindset, my main focus as a tester is gonna be to tick some boxes. Ticking some boxes is not very nice detective work, and testing should be a lot of detective work. Should be a lot of experimenting. Should be, it's scientific, right? I sometimes shouldn't know what to expect, but I will use my kind of gut feeling to detect if this is a defect. Either way, test cases kind of make the work less interesting, if you ask me. Of course, they kind of guarantee, they give you this sense of comfort, but they kind of also take away a lot of the passion from fellow testers, if you ask me. Subjectively speaking, all right? Cool. So, quality assurance I've kind of put it in a very bad light now. Don't get me wrong, I respect it deeply. So quality assurance is easy to implement just because everybody knows quality assurance. Everybody knows what to expect. Everybody expects it as a process. So it's kind of easy to have a very structured manner and making things kind of easier to predict. And it works. It does a fair job. We've been using it to deliver software for years and years now. It's been adapted to the agile mindset. And depending on the people applying it, it can work amazing, right? So all of the downsides that I mentioned can definitely be addressed by people who really mean it. Like if the whole team really means it, if the whole team, not just testers, that's the issue with quality assurance, because it doesn't have expectations from your developers when it comes to quality. But if both developers and testers understand the value of quality and understand some philosophy behind the quality of software, then quality assurance is going to do an amazing job of keeping things nice, predictable, and defect-free. Cool. So I haven't even talked about the process that I will talk about, and the process and the philosophy that we are going to talk about. So we've only talked about quality assurance up to this point. So what's the alternative? Well, that's what I asked myself a couple of years ago, just because of the issues that I kind of told you about. So what would be an alternative quality model that addresses the issues that we just talked about? Well, it seems that I'm not the only one that kind of was bugged by these issues. A very nice team at Atlassian had these questions as well, a number of years back, and they came up with this concept, which they called quality assistance. I know it's still QA, but so that the change is not that big, basically. So when naming it, I mean, so quality assistance. This is what we are going to talk about today, and we are going to refer to the issues we just talked about and how quality assistance kind of addresses them. So quality assistance comes with a philosophy and a process. So it's a mindset and a process. It's almost like Scrum and Agile, right? Scrum is a methodology. The most important part of Scrum is a methodology, and Agile is a philosophy. It's a mindset. So quality assistance comes with both. So we are going to talk about the mindset first, and then we are going to look at a bit of a process and how you might implement it in your team. So first of all, I would say you would need to ask yourself, what kind of company would you like to implement this in? So it's not a model. This quality model is not fit for all companies. I would say maybe the easiest place to implement such a culture would be a product company. I don't know the hardest, but it's at least anecdotal evidence shows me that the easiest place to implement this is a product company, where you can influence culture on the long term, right? So you can make quality part of the company mission. So in quality assistance, instead of quality being someone else's problem, quality is everyone's business across the board. So I'm talking about product owners, product managers, developers, and testers. The quality team is there to not necessarily test everything and act as a quality gateway for the whole team and feel kind of responsible, feel the only be the only ones responsible for software quality and the lack of defects in a software. They are there to create and maintain a constant pressure for quality without making it overwhelming. Of course, there are a lot of aspects to think about when developing software. So quality is one of them. So the pressure needs to be there, constant, but not overwhelming. We have a lot of other things to think about. The quality needs to be focused on the user experience, on the improvements of the software, rather than the treatment of defects. Quality assurance focuses a lot on defects. Quality assistance alleviates this pressure on the defects. Defects will be there, will be part of the focus, but the main focus is how we present this product, this deliverable, this feature to our customer. And quality assistance, as you will find, is scalable, not in a directly proportional way as quality assurance is. So it's not going to be one tester per 3 developers, no matter how many developers. So if you have 30 developers, you have 10 testers. No. Quality assistance works with less testers. Don't get scared. This doesn't mean we are going to run out of jobs, okay? And the mindset is that rather than kind of optimizing a siloed approach, so quality assurance looks at how can we do things better, how can we remove defects while still working in silos. Developers are developers, testers are testers. We throw things over the fence to testers when we finish something as developers. So rather than working in silos, quality assistance kind of teaches everyone to work better. That's the philosophy again. So in quality assistance, quality doesn't mean testing. More testing doesn't magically bring quality. And of course, more testers doesn't increase the quality. In quality assistance, the basic gist of it is that because it's everyone's business, there's a lot of importance in developers testing their own work. And don't get scared. So this is not going to be testers following test cases. There's a lot of focus on this detective work, this experimental way of finding defects. Exploratory testing is a very important aspect of quality assistance. At the same time, of course, we still do regression. We just regression testing, so making sure that new stuff, new development hasn't broken old features or existing features, not necessarily old, existing features. We do that through automation. There's this kind of idea that was floating around. I think developers will know this guy. His name is Uncle Bob. Uncle Bob said that testers find nothing after good developers do their job. I'm not going to quote exactly what Uncle Bob said, but the gist of it was that, when you, as a good tester, when you test something after a good developer has done his work, you won't find defects. And it's not about not finding defects at all, of course. We're not madmen here. So it's about not finding big defects, but rather finding the finer, the super kind of weird system issues as well, right? So kind of issues that appear when moving from the test environment to the production environment. So big defects should be found by the person developing the software, right? That's Uncle Bob said that. So he's one of the guys that created Agile. He's been a developer all his life, so kind of an advocate, and so a very, very, very smart guy. It makes sense, right? Quality assistance kind of goes into the reasons why defects are introduced, not necessarily the defects themselves. So it's almost like, you want to have a dry carpet, but your roof is leaking. What do you do when it rains? Well, you put some pans so the carpet doesn't get dry, that doesn't get wet. So next time it's gonna rain, it's gonna be the same, right? You again need to put the pans. Next time it rains, again you need to put the pans. Quality assistance kind of addresses the question of how can you should fix the roof rather than just putting pans to keep the carpet dry. So quality doesn't comes from fixing defects. It comes from not introducing defects. It comes from testing earlier, even earlier than the tester has time to test. So yeah, we are gonna look at. We kind of talked a lot about the philosophy behind quality assistance. So we need to also look at how you can implement it. So kind of apologies. So how do we implement quality assistance? Well, let's say you start from a place and a moment in time when you do quality assurance. This is I would say the most probable. That's why we're taking this scenario. This doesn't mean that you necessarily have to be in quality assurance for you to implement quality assistance. So you can be in any shape or form. But short term, your goal as this quality consultant that implements this is, of course, to protect your customers from defects. So even if you have this change in mindset, you still want to keep your customers bug safe. So just to keep that in mind, right? On the short term, you want to protect your customers. On the long term, you want to change the culture of the company you're in and change the quality mindset of the company you are in. A good plan to implement this, of course, is gonna be also measuring your success in the process. You will see in quality assurance a lot of exit reports, a lot of metrics are based on defects. For me, it never made sense for us to have KPIs based on defects. It really doesn't make sense. I don't want to get into the details of it. Either way, for this to kind of work and make it believable, you would of course need to measure and prove that quality assistance has success. So how would you measure your success during the implementation? Well, the customer would be the main actor that gives you feedback on the quality of your product. So start gathering metrics focused on the user experience as soon as possible, and you will see those improving in time. Uh, the development team can see if it's improving not by measuring the amount of defects that are found, but rather how many times do I need to rework a story after I have said it is finished. So, I have finished a story, a feature. I have delivered it. And for whatever reason, design change, the journey wasn't clear, acceptance criteria weren't clear, defects were there. For whatever reason, that story needs to be reworked. Well, that feature specifically needs to come back to its in progress state column, whatever you use to manage your tickets. We should measure this. How many times does a story come back? Or rather, how many stories do come back after we said, oh, it's finished, and it wasn't actually finished? The guys at Legion that I was mentioning kind of implemented this first. They had a story rejection rate, that's how they called it, a story rejection rate of 95% when they started measuring this. And I think they ended up with something around 5% after a couple of years. So this is a lengthy process. Don't get me wrong, this is going to be a lengthy process, right? But think about this. So after 2 years of working diligently on implementing this approach, quality assistance, they managed to deliver like with an amount of certainty, which I would say is unheard of in the software development industry. So when they say it's done, it's done. It means it's of good quality. It means that the designs were right. It means that the specifications were right, and it can reach the customer from the first time. So you don't need to rework. All of the investment that you put into this process and philosophy paid up. You don't need to turn it back, change the mindset, change the kind of offload things, start thinking back again about the defects that you need to fix and stuff like that. And so we are talking about the KPIs to measure our success while implementing quality assistance. So the third would be the test team itself. So how is the test team? What is the perception on the test team, right? How well they are kind of evolving along the development teams. That would be the third KPI. I'm not even sure if this is more my recommendation rather than the original way in which Atlassian put it. So there is a bit of policing around in quality assistance, and you want that policing around to be always with the customer in mind, always with the product in mind, always with a goodwill, right? So we need to consistently apply a process across all development teams that improves these KPIs, that changes the culture, that brings quality assistance. Cool. We are also going to look at, hopefully this was clear enough about the mindset, the philosophy. It's hard to kind of talk about mindset and culture in such a short format. This would be fitting for a workshop. Questions would. I'm sure that you have a lot of questions in your mind now. Hopefully, this next part will kind of answer some of those questions. So we are going to talk about the process itself. How can this thing be implemented? So again, we are talking about this delivery cycle. So a sprint, right? We are talking about agile here. Most of the teams I've worked with were agile teams, or at least struggling to do agile. So we are talking about this release cycle. This is usually 2 weeks, 3 weeks, whatever. Now, when a feature is refined, the tester's role is gonna be the same. The feedback is gonna be there. Your unique testing perspective is very helpful. So you would kind of come with your feedback on the story exactly as it happens in quality assurance as well. In this moment, especially if you're a new team and if you want to do, let's say, a proof of concept with quality assistance, I would say this would be a perfect moment to identify maybe a feature that can go through this quality assistance process. I've seen teams in the past use labels to say this. So let's say, guys, we are trying out this new process. So let's put a label on certain features. Let's say it's not the most critical features. The impact, maybe it's not there, but they do need to be somehow complex, right, to prove the worth of the process. So this is how I would start a proof of concept or with quality assistance. I would maybe identify the features which are a feature which would be worthy for this process in this phase by a label. After the refinement is done, whatever basically the sprint has started, before development starts, I, as the tester in our team, would sit down with the developer or developers who start implementing this. So sitting down means actually having a meeting. This is anywhere between 15 minutes and 30 minutes. I call this meeting the pre-development test hat session, because the most important thing in this meeting is wearing the test hat. And not just for you, the tester, but the developers as well. So the challenge is going to be to force the developers to kind of think outside of the algorithm. They've already thought about that. They understand the acceptance criteria. They understand the implications of the journey. You also, as a tester, understand these things. So you all wear the testing hat. So how is this thing gonna be tested? We usually capture this session in something that we call test notes. So not test cases. It's very important to not use test cases here. It's very important to not be imperative in this moment. So we capture test notes. Test notes are open questions, prompts, hints, tips to thinking critically and exploring the feature after it has been finished. So we're not talking about checklists. Again, whoever tests this after it has been developed cannot get away with just ticking some boxes. He needs to think critically. The responsibility is on him. So test notes are questions like, maybe what features are impacted by this feature? Where does this information appear on the website? What third parties are triggered when we use this feature? What happens in situation X? If it's not clear from the acceptance criteria and the initial specification, ask the question. So these are the test notes, right? You capture them, you put them right there directly next to your ticket. Of course, if they are super important and big things are missing from the story, then you need to send it back for a refinement, and these questions need to be answered, before you can actually continue working on it. So, you've done this. You've taken your developer before he started developing something and put him through this exercise of thinking about what can go wrong before he actually starts implementing things. Now let's think about this. What How does this bring quality? Well, first of all, it puts the developer in this mindset. What can go wrong? Before he is biased with the implementation that he is gonna basically, the brain gets biased. Anybody gets biased. That's one of the, I would say, most kind of biggest justifications for the existence of testing. You need a fresh pair of eyes to look at your stuff, because you as a developer get biased once you start implementing a certain algorithm. The brain is going to be biased to only test the routes that you have implemented. So thinking about testing first kind of removes those biases, because you've thought about testing actually before implementing this thing. It will remove most of the big issues. So just by doing this, will remove most of the big issues, will prevent them from being introduced. Again, we are talking about the kind of source of the issues here. It's very important. Cool. After development has finished, the developer who is responsible, developer or developers who are responsible for developing this, are gonna do their own exploratory testing session. Now, exploratory testing, as with many other terms in our profession, is a loosely understood concept. So exploratory testing kind of means learning while testing. This doesn't mean that you get in stupid and you just click random buttons and you do monkey testing. This means that you know a lot of stuff and you are open to finding new things. It means that you need to do critical thinking. Exploratory testing doesn't mean that you kind of just, I'll start testing, you click around stuff and, I finish testing. So it's not a random way of approaching testing. It can be and it should be very structured as well. So, we structure our exploratory testing sessions in a specific way. I would recommend this way, of course. You will see that a lot of experts in our field kind of recommend this way. I'm talking about, of course, James Buck and Michael Bolton, who have this very amazing rapid software testing course, and exploratory testing that way, I would say, is the best way. So, but yeah, maybe I am biased. Either way, exploratory testing should be a combination of exploring and structure. So a combination of letting loose and critical thinking and limits and kind of plans. That being said, the way we do exploratory testing is we establish a kind of a charter. So, what is my mission for this session? It should have a time box. The brain cannot stay focused for more than, maybe 1 hour, an hour and a half, 2 hours, maximum 2 hours, I would say. So time box it. Don't allow outside interventions. It's like you're in a meeting. You cannot answer for these 2 hours. I don't care what is burning. I cannot test your defect in production right now. I'm sorry. Well, take it with a grain of salt. Maybe things are important enough for them to be tested and interrupt your exploratory session. But either way, don't allow yourself to be distracted easily. Draw a mind map of things that you are gonna test. Again, as a developer, so I'm talking about the developer conducting an exploratory testing session now, right? So I'm suggesting to him, draw a mind map. 5 minutes. Take 5 minutes to jot down the overall idea of what you're gonna test. Read your test notes. So what has been captured during the pre-development test hat session, when you were thinking like a tester before developing your feature, read them now. Make sure you go through all of them in this session. So make sure that mind map includes these test notes. And start testing. Think critical. So don't allow checklists in there. You don't need guardrails, right? You need to allow your mind to think critical. Learn heuristics. Ask, or I'm not even sure who I'm talking to anymore. So let's say talk to your developer or teach your developer to what a heuristic means, what test heuristics mean, and you will find cheat sheets about heuristics all over the place. Teach him basic testing techniques, like the basic ones, equivalence partitioning. I'm sure that most of the developers kind of understand that in their soul, but what it means to kind of only choose one value from a partition, which is, which choosing any other value would be equivalent to choosing this value. How defects tend to appear in the boundary values, right? Teach your developer these kind of things. And also teach him not to get carried away with defects. So when you find the defect during an exploratory testing session, don't sweat it. You found it, note it down, 3 minutes, note it down, explain just a bit what happens. So you found it, okay, you explored it a bit, you found it. Jot down a couple of things about it, and that's it. How I would do it, I would usually record my screen during these sessions as well. So press record, and I would note down that, okay, I found a defect at minute, 45. And I know that at minute 45, I will have this defect, in my recording. So when I finish the session, I'm gonna go in deep into this defect. Until then, I will focus on my exploratory session. So at the end, I will have a list of defects, which none of them I've explored in depth. But after I finished my exploratory session, I can actually start exploring these defects, and I can actually start maybe raising these defects in my defect management tool, right? After the exploratory testing session is done, keep in mind, so I'm gonna kind of remind you that we've been talking about the distance between introducing a defect and finding a defect. Remember that, right? In this scenario, the developer, when he does exploratory testing, the feature needs to be, of course, deployed in a testing environment. Okay, that's fine, but deployed. So he's actually testing the feature as a customer would see it, not just from a technical perspective, right? So I, as a developer, have introduced a defect. Then I've done some more programming. I finished the feature. And then right after I finished it, I am testing it. I will find a defect. All the information about this feature that I've just developed is still here. All the algorithms, all the logical architecture that I've implemented there is still in my head. So I haven't offloaded things. I haven't switched kind of contexts. I'm still in this feature. So I can fix this defect potentially without introducing new defects. Potentially with kind of keeping the pattern of the design that I have just implemented, rather than forgetting about it and finding this defect 1 week from now, when some of these things I won't remember. Okay, cool. So I have tested it. Cool. So we've talked about identification, the pre-development test session, the developer exploratory session. So we've talked about these three phases. Let's go to phase 4. So phase 4 is the quality review. So you get your developer, you as a tester, right? You get in a short meeting with your developer and talk about how it was tested. So how did you test this feature? This can also be a demo, but the most important thing is, does it look and do what it should? What has been tested? Have the testing notes identified in the pre-development test session meeting been addressed? So pre-development test hat session, you know what I'm talking about. Does it need further testing? Does the quality engineer also need to run an exploratory session on it? So you ask these questions. Use this chance, as well as the pre-development test hat session, to share your tester mindset, to share the testing techniques. When you notice something has been missed, share why do you think you would have kind of addressed that thing as well. Testing is not an easy thing to learn, and the tester mindset is not an easy thing to put in theory. It is a lot of experience based. Yeah, you're right. So use these two sessions, so the pre-development test hat session and the quality review session, 15 to 30 minutes each, right? So we're talking about an hour per feature. It's not a lot, right? An hour per feature. Use these to share your tester mindset. Use these to improve the way your developers are testing and the way your developers think about quality. Cool. Now, if during this quality review session you feel that mistakes have been made, testing is not sufficient, whoever did it, it's the first time he does testing in his whole life, so you feel that big things might have escaped, right? You feel that this feature is big enough, is critical enough that big things might have escaped. So before it is deployed to production, you do your own exploratory testing session. The exploratory testing session is going to look the same as the developer's one, so that's what I would recommend in quality assistance. Of course, you would also run automation on the things to make sure that the old things haven't been broken. So there is no manual regression in this process. There's only this detective, destructive work involved that appears in exploratory testing sessions, right? So that would be, I would say, a first step to start implementing this quality assistance mindset. Keep in mind that all of the phases that I just talked about, so the pre-development test hat session, the developer exploratory testing, the quality review, and the quality engineer exploratory session, can be implemented using what we call a developer on test. So rather than you being the one who holds the developer's hand while going through this process, for teams that for development teams that don't have any testers in your company, in your current company, you can push your developers to wear the test hat and be that fresh pair of eyes when there isn't enough experience to go live comfortably. So that this usually works with teams that are already very well versed in what quality means. So this is something that it's still debatable if it works or not. I haven't been yet able to implement it successfully. So, leaving quality just in the hands of the development team. But what can I say? What I can say is, for development teams that they know they have a quality issue, and they are senior developers. Senior developers are gonna be interested in the quality they produce. Juniors, mid developers, some of them won't care about quality because quality is someone else's problem. That's not true, my friend. Quality is your problem. You're developing that. You are showing it to the customer. You know that there's nobody's after you kind of testing. So you need to make sure that you are releasing something of good quality to the customer. Yeah. So this would be a kind of a process through which quality assistance can be implemented. That's I would say would be it. So we've talked about the philosophy behind quality assistance, how it addresses the issues that quality assurance currently has, and a potential process through which you can implement a proof of concept and later on improve upon. I encourage you to read about quality assistance. This is not something I've come up with. This is something that more and more people started implementing after Atlassian. So a lot of people picked this kind of example from Atlassian and brought it into their own company. So you will find a lot of success stories out there. Understand that, give it your own interpretation. Don't take my word for it. Give it your own interpretation. Adapt it to your company. Make sure. Ask yourself if your company is well fitted for this kind of thing, and know that you will be asking from your testing team that they should be actual seniors, people doing test automation, which, by the way, you will have a lot of time to do in quality assistance, a lot of automated testing, because time is not spent doing manual regression. So doing automation, doing quality consultancy, right? Looking at the process as a whole and understanding where quality issues come from, teaching others, so teaching developers how to test. Developers are sometimes not willing to test, so that might be a tricky thing to do. And getting better at manual testing at the same time. Manual testing, which is the only type of testing, right? The only type of destructive testing. Detective testing. The other ones is almost like how Brian Merrick calls it, preventive testing, right? So automated testing is preventive testing. You're making sure you're not, you're not damaging the features that you already have. The destructive testing, the detective testing is the scientific testing. Let's say the experimental testing. That's the nice kind of testing. Cool. Thank you very much. This has been Victor, and I'm hoping you will give it a try and at least look at, maybe read some more material about quality assistance. Decide for yourself if it could work or not. Thank you.
Learn from our experts how to feel it, live it, be it. And make sure to follow us on social media at Life at Software Mind.